Welcome everybody. Welcome to our lecture on linked list. Actually, we are discussing chapter 3, dynamic data structures. So as you know, the linked list is a widely used dynamic data structure, and a linked list is a data structure in which the objects are arranged in a linear order. Okay, so linear order, that means more likely as a regular array. Okay, so this is why in most of the programming languages now there is a built-in linked list that is called array list. Okay, so but unlike array list is a dynamic data structure. Okay, so actually there are two kinds of linked list. One is called singly linked list, another is called doubly linked list. Okay, so that means in a singly linked list, okay, so what happens actually, so let us see. Actually this linked list, if you took my data structure course or CSE 1322 course, then you should have known this. Okay, so you see that this is a node. All of these are nodes. Okay, so each node, okay, each node, it contains a data. Each node contains a data. Okay, and okay, so in a single linked list is not knows who is the next, who is the next. Okay, in a single linked list it has two parts. One part is data, another part is called link. Okay, but in the doubly linked list, each node has three parts. An addition part that is called that knows the link of the previous node. Okay, so here in the middle one, if you see that, so that means the initial, this is an initial, that the head is null, or and the all the end there is that is there's a tail, whatever we say, is actually it's called previous node, and then next node is null. But all other in between nodes is nodes, so this node is links with this one, and this one is linked with this one. So this is a doubly linked list implementation. Okay, and in a singly linked list we will have only one kind of link. Okay, so in a linked list, like as a dynamic data structure, so we need to mainly know the basic operation, how to insert in a linked list, and how to remove an element from a linked list, and how to search. Okay, and so let us see our slide next. Okay, so as an array, we know that an array is a static data structure, but array list or linked list is a dynamic data structure. Okay, so the dynamic data structure, so linked list, since it is sequential, okay, all elements are linked together one after another. Okay, so deleting, and the first one we need to let me discuss about the insertion. Okay, so insertion in a linked list, it can be happen at the beginning, at the end, or at any position. Okay, for instance, we have this initial list, array list with A, B, C, D, and E elements, and we want to put an element N. Where do you want to put an N? We can put N at any position, but if we want to put N at the third position, right after the second element, so what is 3 right now, what is C right now, so then we need to do, we need to move all other elements to the right, right side. So for instance, first of all, we need to create a new node position over here, the 5 one over here, and then move second one, move E to the 5 element 5 node, and D next D to the 4th position, and then C to the actually E will go 6th position starting from 0. Okay, so E will go 6th position, D will go 4th position, and then and so on. Then we will move C to the from 3rd position to 4th position, and then there will be an empty space over here, and we will move in. We will push or insert in over here, right? So if we want to insert at the middle, or we say in between, then there is a sometime we need to need a few more tasks, right? But if we want to move, we want to insert and at the end, that is easy, right? Okay, and then deletion, what do you mean by deletion? For instance, we have items in a linked list A, B, C, D, E. So for instance, we want to remove the elements. Okay, we want to remove the elements from its position in the element C from its position. So what do we need to do? We need to remove this. Okay, and then we need to fill the gap. Okay, and there are actually the an intuitive way actually, that while we are actually we can do two things actually. Whenever we want to delete this one, we can just delink this node. Okay, so that is deleting means unlinking an element. Okay, and then we can, if we want, then we can move the other elements here. Okay, or we can move the other elements, or if we link the previous node with the following node. Okay, we can do that. Okay, so there are pros and cons for addition and deletion operation in linked list. Okay, so but so let me see that what do you have. Okay, so here actually what we want to do, so in our 1322 course and in data structure course, I think you have learned about singly linked list implementation. So in this actually lecture, I want to discuss the doubly linked list implementation actually, and especially the search operations. Okay, and then if I have few minutes, then I will discuss array list, the built-in linked list. Okay, so I will come back to this slides later. So if you go to my Replit account, so that I have a complete program that is singly linked list implementation example 1 in C#. Okay, so this is the program name, and also I have this one in Java. Okay, so let me explain this briefly. Okay, so as we discussed in our previous lecture, that a node class is the main element or ingredient for all linked list, stack, and queue. Okay, so a node class, it can contain any kind of data. It can contain integer data and then string kind, boolean kind, other kinds, or it can be combined. It can be complex data type with the combination of one of types. Okay, and mainly this a link, a node, it contains itself. Okay, we will come to soon why do we need this. Okay, and then a node, a class, it contains a constructor. So its constructor is simple and it has a display a node and two string method. Okay, and sorry, whatever you want, you may have more methods over here. Okay, and linked list, it is singly linked list. Okay, so this is singly linked list class. Actually this class contains, this class starts in line number 33, right, and it ends in line number 307, right? That means this program is quite longer, right? So it has actually a number of methods. Okay, so all of the methods are implemented here. So what are the methods? See over here. So linked list, this class, it contains a node. Okay, we can say head. Actually for a singly linked list it will contain head, and in doubly linked list it will contain both head and tail, or previous, we can say head or previous or next, head or next, or head or previous, whatever you say that. Okay, no problem. And this is empty linked list constructor, and it creates an empty linked list and is empty method. Okay, so how do we find it? A linked list is empty if head equal to null, right? Then it is empty. And mainly, okay, so there are multiple methods for insertion, two methods for insertion operation. One is called prepend, another is called append. Prepend means if you have already one existing node in a linked list, and if you want to add another node, okay, before the existing node, okay, then that is called prepend. And append, that means if you have an existing node and if you want to add a new node after the new node, okay, that is called append. So prepend and append operations are same if our linked list is empty. Okay, so if our linked list is empty, then there is no difference between prepend and append operation. Okay, but if our linked list is not empty, that means it contains at least one element. Okay, but if we want to do, for instance, an append method, okay, for instance, for append, that means if there are some existing elements in the linked list, then what do we need to do? We need to go through all the way in, okay, all the way in to the last node, and okay, and from the last node we need to go next, and we need to add to the to the new node over there. Okay, so if I show you for instance here for the append. Okay, so if you want to append, so we need to, you are starting from here, then you need to go here. Actually this is this is doubly linked list. Okay, so no problem. So actually what we need to do, we need to go from beginning to all the way end, and then we need to add an element over there. Okay, but for the prepend, okay, so for the prepend, what do we need to do? We need to add at the position at the what is that called, we can say before the left side, or before the node. Okay, so that means we need to add an element and we need to connect the head field to the next, the new head. Okay, so how do we do that? We can do like say new head dot next equal to head, and head equal to new head. Okay, so this, I think you understand, you know, a prependent operation from 1322 or data structure course. Okay, so but in this course let me remove focus on the remove the first element. Okay, so if for removing an element we need to check whether it is an empty. If it is an empty, then okay, so then we need to return, right? Otherwise, if it is not empty, then we need to go head equal to head dot next. Okay, that means, and we need to just how do we remove the element? We go to head dot equal to head dot next. That means what we are doing, we are unlinking the first element. Okay. Okay, so this is all display all nodes, and it is simple one, and then find by ID. Okay. Since in our node has ID and name, so we can find either by ID or by name. Okay, so the ID needs to be IDs are unique, then it's good, then we can find by ID, or name is unique, then we can find by name. Okay, but if that is not unique, then if there are duplicates ID or name, then the task is difficult. Maybe we are not discussing this here. So this is the find by ID operation. Okay, and so similarly we can find by name. Okay, and similarly we can do remove by ID, and we can do remove by name. Okay, remove by name. Okay, so this is the linked list class implementation, and it is about 200 lines, right? Actually, now let us think about actually how let's discuss how the linked list actually work. For instance, let us think that we do not have the linked list class. We have only node. Okay, so then we created node n1 equal to new node with id1 and n1 is name. Okay, and then so on, we create 6 nodes, and then we display 6 nodes like as here. Okay, so then what will happen, for instance, let me cut this for now. Okay, I want to don't cut me, let me so what will happen, so for instance let us run the program and then we discuss. So here we just created 6 node, individual node. Okay, these nodes are not linked. So for instance we are discussing that we do not have that linked list class, that linked list implementation. Okay, so the all of the methods, insertion, deletion, the append, prepend, find by ID, find by name, we do not have this, for instance. Okay, for instance we simply have these nodes. Okay, so then we display, we just display this. Okay, pretty simple. And then in this case these nodes are not linked. Okay, so then linked are not, for instance, then what will happen, every so this needs, okay, so these are not linked, so since these are not linked, if we say that n1 dot next, if we say n1 dot next and n2 dot next, what you will see that actually there are, since these are not linked, so n on dot next will come as null, right? So remember that what our next element was. So every node it contains another node that is called next, right? Okay, so this is the next over here. So n on dot next is null for all into dot next null, and everything is null, right? So over here now, then how to link that? We can link manually. We can say n on dot next equal to n2, that means n on is the first element, n2 the second element, and n2 dot next equal to n3, that means n3 is the third element, and n3 dot 4 equal to n3 dot next equal to n4, that means n4 is the fourth element, and so on. And n6 dot next equal to null, that means this is the last element. Okay, and then if we link them this like this way, and if we print the same statements, this same statement over here, then what will happen, then at this point we will see, you will see, if we run this program, then we will see that n on dot next equal to, it will print n2, n on dot next equal to n2, and n2 dot next equal to n3, and nc6 dot next equal to null, right? Okay, so and at this point, so if we now if we print display a node method, for instance display a node method, now if we print that, so for instance let me print up to this. Okay, then it will print n1 and 2 this nodes. Okay, so actually we don't need this, maybe we don't need this. Okay, now but instead of linking this manually, what we are doing in a linked list, we are creating a linked list class. This linked list class contains all of these methods, linked list implementation. Okay, so that for instance linked list class, we are creating an object, the linked list object, and initially this will be an empty linked list, right? And then now we are calling the prepend, append, all of this method. So whenever we say call prepend, right, prepend, that means we say prepend, so actually initially this is an empty, right? So initially prepend and append is same thing, that 0 will come first, and then when we say append, then 1 will be then next, and then whenever we say prepend, that means what will go over here, think about a second. So prepend, that means it will come the front, and append it will go all the way next. So with some prepend, append, prepend, append, prepend, and append, we will have a list. Okay, so now if we display all nodes, actually it will print all nodes. Okay, so let us print, let's have the so we will see output before my mistake. Line number 391. So we'll see the effect of the display all nodes method. So for instance, when we made prepend, okay, so that means 0 is initially empty list, so 0 will be the first element, and then when we say append, a will go after 0 and then 1, okay. A will be the second element, this one will be the second element, and when we say prepend 2, then this will be the top element. That means this one will be the first element, this will be second, and this will be third element, okay. And you say append, this will be the fourth element, and then prepend, so then this will be the first element, okay. And whenever you say append, then this will be the last element. So you see here, so 5 is the last element, and prepend 4, there will be the top element, first element, and this one, how many prepend we have? 2. This one will be the second element. So it's easy to go this way, okay. So from the bottom, so prepend, that means 4 will be the first top element, and then 2 will be the second element, and this 0 will be the third element. You see the 0 will be the third element, and then now it goes append, right? So append will come from top to bottom, okay. Then this will be the fourth element, and this will be the fifth element. C will be the fifth element, okay. And oh, so this one will be the D. Oh, D is prepend, so append is the last one, okay. This one will be the last one. And so okay, so now if you go through this remaining task and remaining course, and I like you to disable some of the course, comment out some of the course, and then run it and then analyze the program, okay. Okay, and this implementation is in Java, and similarly I have this implementation of single linked list in C#. So in a C# we need to make this public, otherwise the default does not work. In Java we have default modifier, right? But C# we need to explicitly make it public, and there are some differences. You know that the toString method implementation is different, okay. Otherwise the implementation is almost pretty same, 90% is same, okay. Then we have doubly linked list, okay. So please give focus on the doubly linked list. So in the doubly linked list we have node, okay, but this is the difference in doubly linked list. Each node has two other links. One is called previous, another is called next. So whatever we say previous or next, you can say this one first, you can say this one next, no problem, okay. And then otherwise the node class is same, node constructor is same, display method is same, toString method is same, okay. Then this is the doubly linked list implementation class, and since it has both head and tail, so actually, so that means each node had both previous and then next link, right? So you can say this head or tail, or you can say previous or next, whatever you like, okay. That is not an issue. So it is constructor, default constructor, and it has prepend method, and it has append method, okay, and display wall method, and then iterator forward method, and iterator backward method, and remove the first and remove the last, few methods, okay. You can implement find, search by ID or search by name also, okay. Let me explain a few. since it has both two links, right? So both head and tail, right? So we need to consider, we need to link both head and tail. Okay, both head and tail. So this is why implementation is a little bit is tricky than singly linked list implementation. And I believe you learn this in your data structure course, but for this course we just we are just reviewing data structure. We are not going in depth implementation of singly linked list or doubly linked list, but we want to analyze, right? This is analyzing course. So what is the analyzation? Actually we need to understand here. For insertion and deletion, okay, at the beginning of a linked list are very fast, and then whichever you say is constant time. Yeah. Okay, and the finding, okay, what deleting, okay, an element depends on the situation. Okay, so if we need to search all the way for a specific element, then it will be big O n times. Okay, in the worst case we need to go all the way end to the list to find an element, a node. Okay, so it is more similar to finding or searching in a like a traditional array element. Okay, okay, so here are the some difference between linked list and array. Array means traditional array. Okay, and now let me go through the remaining steps. Okay, so this is doubly linked list implementation in Java, and I have also doubly linked list implementation example in C#. Okay, so there are few differences. One thing maybe I should you should know that. So there is no such element exception. This I use this one in okay in Java, but C# does not have this exception, but it has rather a different, it is called invalid operation exception method. Okay, so otherwise, and it is defined in the system class, so you need to use in system. And then otherwise twisting method implementation is different, and otherwise these are pretty same. I think this code should run. Okay, so these are the implementation of a singly linked list and doubly linked list. And actually okay, so you please read the book, you please read this this section 10.2 section from the book, and you will get some quiz question from here. Okay, and then you can read the slides, and you can see the implementation in actual live real implementation from my code. Okay, I have for program. Then once you understand this, and then you can implement this in any language. Okay, thank you so much, and I will see you again.